Welcome to the security panel, and thank you both for our distinguished auditors and for Mooly for that exciting overview. And hey, I'm Tomer. As you probably noticed, I'm not Lee, who was supposed to moderate this panel. Is not here anymore, so that's great. And before we dive into it, I'll just share that I would say more than a year ago, Mooly invited me to the DeFi Security Summit, that happened in Paris. And I arrived there, I listened to all these great people talk about DeFi hacks, and I got a panic attack, basically. And so I think what happened after that is that by the time Meridian happened last year, we have already put together both this partnership we had with Certora and also the audit bank with several auditors in the space to kind of like make sure that we're putting security ahead of the curve in the Stellar ecosystem. And I am curious, maybe before we dive into like super technical questions, it's been a year now that you've been working with the Stellar ecosystem, and I'm curious, what did you learn? How do you feel about the Stellar ecosystem in general and security specifically? And maybe we can start with you, Mooly.
Yes, so Certora, we took this project. We were very excited because we have a lot of experience in securing protocol, and it's damn hard for us. It's very, very hard. I told you it's formal verification, but in fact, most of the time we are finding bugs, and we are finding a lot of bugs everywhere, in the compiler, everywhere. So we thought this is a cool, nice project, and we won't find bugs, and it will be very easy for us. So we are actually finding bugs, and it's not so easy for us. I think for us it's very tricky to model the environment, and I think we learn. We get better, but initially we didn't understand. In the EVM it's very hard, but once you get each instruction, we kind of understand. In the Stellar, it's the WebAssembly is easy for us, but the issue is that understanding the environment. I think I like Robert's talk about the storage. Actually, we still don't understand. Actually, that's very nice. So it sounds like you guys. The good news, you guys innovated in a very nice way. I remember. Thanks, actually. But this innovation is still for us, and maybe it's not politically correct, but it's hard. It's hard. We still need to understand. I think it's very interesting. We have a very clean model of the storage. I think also talking to you guys, to the Stellar, I see that you guys understand the domain very well, and you did a wonderful job with the design of the smart contract. But still, for us, because and also maybe we took the wrong decision, but we decided to verify the executable code. And maybe it was in retro perspective, maybe we should have taken another level.
Yeah.
But this is what we do in all the projects we do. We take the executable code and we want to verify that, and some people say it's the wrong decision, but it's taken 6 years ago and it's hard to change. But it's a tricky decision, but anyway, I did too much. I said I let other.
Yeah, well, clearly Mooly is an engineer, not a marketing person, if he's talking about making mistakes. Thank you. And congrats on launching your first WASM integration, and specifically Stellar. Very excited about that. Live today, by the way. You can already go online and check it out.
Yeah, and big thanks to Johannes, who is here for the UI, and Chandra, Eric, and all the people in Seattle that couldn't come.
Sorry, what was the question again?
The question is about kind of like impressions on like a year of working with the Stellar ecosystem.
You are the best to know all the.
Right. Yeah, I think for us, Stellar is a very interesting ecosystem to work in. And I know I talked a little bit about how Stellar has some unique parts, but I think the one impression we got from Stellar is that everything's very well designed, right? So sometimes on other blockchains, we'll see some feature or some design paradigm that we go like, why did they do this? Or it doesn't really make sense. But for Stellar, they very carefully thought through each of these design decisions, and there's a trade-off, right? When you want some complexity because it lets you be more performant. For example, the reason why Stellar has all this TTL stuff, which is kind of complicated as developers to think about, is they don't want storage staying around forever, right? And it makes sense. It's something that is intuitive, and clearly good for the health of the ecosystem overall. Yeah, so just overall, it seems like it's a very interesting ecosystem to work with. There's a lot of cool design choices, and I think part of our job is just figuring out those design choices and the implications and seeing if there's any bugs we can find.
Curious, specifically, Robert, you work with a lot of other ecosystems. What are the kind of like differences you see between these ecosystems and Stellar?
Yeah,
and you don't have to talk shit about any specific ecosystem unless you want to.
Yeah, I mean, we're neutral service providers, but well,
Good marketing.
yeah. I mean, one thing, for example, one thing that we don't like a lot, which Stellar does not do, is asynchronous execution. And I think, I mean, when I say I don't like it, I don't mean that it's bad per se, but I think it's very difficult to audit. So, for example, I know Near has asynchronous execution. Ton also has asynchronous execution. My impression is generally those ecosystems have really, really smart core developers who think that all the developers building on top are also really, really smart. I mean, which is not always the case, right? Because sometimes you rush to mainnet or you have other product considerations. I think Stellar is in this nice middle ground where it's not too easy to build on, but it's also not too complicated. And if you're struggling to build on Stellar, at least you're not building on something with like asynchronous callbacks, right? Every time you do a contract call, you have to think about a callback, which is
like how to roll back and stuff like that.
Yeah, which is horrible to reason about.
Yeah. Okay. Daniel, runtime verification, I think is a really interesting place because obviously you do a lot of audits, but there's also a lot of tooling and like formal methods that you've mentioned. What are your thoughts there?
In terms of working with Stellar and across the different range, security's, I think, definitely at the forefront of the mindset of the Stellar ecosystem, and I think we see that in a number of different ways. As you mentioned, you've had the audit bank going. You've tried to help at the application level for projects to have more guarantees in their code coming from people scrutinizing it. There's tooling, Certora, with their tooling to make sure that the WASM verified. There's even support for us doing WASM verification with our tool Comet. And more than just that, there's also a lot of conversation around the infrastructure that boosts Stellar up. So whether that be trying to get strong guarantees out of the interpreter that runs the runtime, the RPC protocol, there's a lot of things that are happening at Stellar, whether it's pen testing, whether it's audits, whether it's formal verification, and it's not just at one position, it's across the entire stack to try and get confidence in the whole entire range.
Okay, we've talked a lot about formal methods. Mooly presented Sunbeam, and Daniel, you have also mentioned some like prop testing and stuff like that. So I actually want to ask Robert, what do you think about like formal methods in general? I think there's a case that these people around you are trying to make is that it's very easy and achievable, and developers should start the project with a spec. Is this realistic? What are your thoughts there?
We're on the other side of you.
Right. I have to be careful what I say. Yeah, I mean, to be fair, I think I disagree a bit. I think that's why you asked the question. I mean, I think formal methods make sense, or they make more sense in the later stage of a project's lifetime, right? I think the main issue that I see with formal methods, and I mean, we do some of this as well, right? We do some formal verification. The main challenge, I think, is writing the invariants, as Mooly said it in his presentation as well, right? A lot of people think formal verification is a silver bullet, where you verify some stuff and you catch everything. But I think the reality is you need a really smart and competent team, like Certora or Runtime Verification, to write those invariants for you. Or, I mean, maybe not for you, but to help guide you on what sorts of invariants you want to write. I think realistically speaking, if you're a new team and you come into formal verification, you try to verify your protocol, I wouldn't be super confident about that, right? I think you wouldn't really understand what are the important things to check for. I think really, it's similar to auditing in the sense that you need to have this history of looking through previous examples and finding the bugs and applying those bugs and writing specifications for them. And we do mostly auditing, so I think auditing is a bit cheaper and comparatively less effort, at least earlier on in the project's lifetime. So I think it makes more sense earlier. But Mooly and Daniel might disagree with that.
I agree with Mooly. I think there needs to be a left shift of formal methods to empower developers to be able. These techniques aren't a guarded secret by us. We want developers to be empowered to use these things, and I think that makes. Yes, it's a challenge, certainly, but it makes for a better experience overall if we can overcome this, because instead of handing off the responsibility of these checks away, the audit being the checkbox and all the power being at the auditors is difficult, because you look at a snapshot in time almost. We want this to be part of the development cycle. I at least agree with Mooly on that. Yeah.
I also can tell you that, look, of course you are right. Sometimes we have cases but we do have protocols like Compound, Maker, who knows how to use our tool better than us. So they have an advantage on us because they understand the code. Actually, sometimes it happens. I remember the first time we worked with Compound, we showed them the spec. They say, why didn't you show us before you develop? We want to develop the code differently. That's how V2 came. So they say, we just want to get the spec. So I agree, spec is hard, but if you try, you start your spec after you write like OpenC, you write 2,000 lines of assembly, it'll be very hard. If you try to write a spec the earlier, if you type even before you even talk to us, like you saw in Daniel, write it in English. You write it as part of your white paper. You write it in TLA+. You write it in, there's some system that you can write in some kind of model. And yes, it is true that writing the spec sometimes is harder than writing the program. But if you are programming 200 lines, which are manipulating $4 billion, so you probably want to do the best you can, and actually writing the spec, especially like with a system like TLA, you can just simulate. And we found a bug in a huge protocol that carries billions of dollars before they write a single line of code. So if we find a bug earlier, it's also from economical perspective. You go to the audit, you are one of the best auditors, so you're fully booked, I can tell you. So what happened is that they wait for you some months. So for us or for runtime application, doesn't matter. But they can use these tools, and it's true, when the formal verification gives you a proof, you need to check it. Maybe you do some mutation testing, but if the formal verification gives you a bug, at least look at it and see.
Yeah.
Maybe it's a bug in your spec, which is hopefully most of the time the case, but maybe it's a bug on your code. We run the tool on the Trident. This was a sushi which was about to launch, and our tool actually found a bug that allow you to take all the money from the contract. And this found 2 weeks before the deployment. So you want them to find it after deployment? I don't think you want to find the bugs as early as you can with auditing and everything. But auditing is a human process which is very useful and expensive. And also, formal verification is expensive. But if you can do it at your house, you are a developer. So the question is, who is the target?
So maybe, Mooly, before I think we went like really deep into the formal verification rabbit hole. But
sorry.
No, it's okay. I brought it on myself. I do wonder, we had a talk that Lee was supposed to give yesterday, and Jake did, about kind of like a variety of testing options for smart contracts. So maybe before we go all the way to like formal verification and formal methods, which are kind of complicated, what type of testing would you like to see, developers, like the core developers doing these protocols that are kind of like, underappreciated or like, not seen enough today? And maybe Daniel, you can get it started.
Oh, well, the first thing is more testing. I think that something that is generally true of, maybe you'll agree with me, Robert, but when we audit a protocol, often it feels like the test suite could be much more robust than what it is.
Totally agree.
And this is, so obviously Mooly and I are big advocates of formal methods, but the thing is, you want formal methods to catch the really hard bugs. You don't want to be running formal methods into bugs that you could have caught in testing, because testing's fast, cheap, and it doesn't require that much intricate technical knowledge in order to achieve.
So are you suggesting that people are not even doing kind of like basic unit testing and they get
Some of it is hard, actually. Some of it is very hard on the blockchain.
Correct.
Things that are so simple to do in normal program, it's so hard to do on the blockchain. And
you need a range. You need a range from unit testing into integration testing into property testing and fuzzing testing. If you want to be most robust, but it comes to what Mooly was saying is what you're protecting valuable, then it's worth having robust tests for. Yeah.
Got it. Robert, when should a team engage with you in the life cycle of a product?
I mean, as late as possible.
As late as possible?
he has no time.
I mean, no. Well, I mean, realistically, before you do an audit, I think you want to get the easy stuff out of the way, right? And I think that's what Daniel and Mooly was saying as well. If you have time, you should totally formally verify your code. You should totally write integration tests. You should totally write unit tests. One problem that we run into is oftentimes teams don't plan ahead, and we get them. We talk to a lot of teams. We get them early in the life cycle where, they're like, oh, we have to launch next month, right? And we're finishing the code this week, right? And when you're that stage, it's really hard for us to do a good audit, but also for you to have confidence that your code is actually safe, right? I mean, again, auditing is a manual process. We read through the code and we try really hard to find stuff, but you can only find so much. And I think when I say as late as possible, I mean you should think about your timelines, right? And be realistic with yourself. If you think it will take 4 weeks to launch, maybe you should give yourself 6 weeks or 8 weeks. People often severely underestimate how much time it takes for the audit process, as well as the patching process and the testing process. And stuff comes up all the time where we think we can audit it in 3 weeks, and then we find a bunch of bugs. And then we have to tell them, like, look, we don't think we can finish this in 3 weeks anymore. If you're a team, the one advice I would give teams is just add 3 weeks to your timeline. It will save us a huge headache. It'll save you a lot of stress, and I think overall you'll be able to launch safer.
Okay. I have a bunch of more questions, but if anyone in the audience has questions, we don't have a lot of time, please raise your hand. And I will follow up on that, Robert. What does a testable project look like? Obviously, ideally, not writing bugs would be valuable, but like what makes a project easier to audit?
I mean, you'd be surprised at how low the bar is. I mean, really, we've had some projects we worked with that maybe we probably shouldn't have worked with, where it's clear they didn't even run the code on testnet, right? Or it's like the function just doesn't work, or some functions work, but some functions don't work. I think after you finish writing the code, you should give yourself a week or 2 weeks to actually use it, right? That's like the bare minimum, right? Like, don't give us code that doesn't even run.
Hot take from Robert: use your code.
Right.
Use your
Make
thing.
sure it's compiled.
Right. I mean, you'd be surprised at how low the bar is sometimes, right? But I think it's, realistically speaking, it's a spectrum, right? Obviously, if you can spend a year testing your code, we would love that, and that would be amazing for us. But if we get that you have product deadlines and you have to launch at some point, so if you want to spend, I think 1 or 2 weeks is usually what we recommend. 1 or 2 weeks testing your code. I mean, it doesn't have to be super complicated. Just write some tests.
Whether you fix the bugs that got found in the audit or whether you found them first, though, it's still going to make the deadline in the same place. Like,
Exactly.
Digging through, doing tests, and making sure that before you pass it off to an audit that it at least does what you thought it was going to do.
Yeah.
to some reasonable degree.
Exactly. Yeah. If we find too many bugs, or if any of us find too many bugs, your audit is going to be super long.
Yeah.
So it'll get delayed anyways.
Any questions from the audience? Maybe as one last question, what would you like to see in the Stellar and Sorbonne ecosystem? Moving forward, we have some core engineers in the audience, so if you have some grievances, this is the time to share them. But also just kind of like from an ecosystem perspective.
I brought a list. More tests. Yeah, I'll just say that test as much as you can. I gave a talk on it. If you can write out the invariants and the specification and then write tests for each one of those, that'd be good.
Yeah, maybe more public goods. I think sometimes we see projects that reuse a lot of code.
Like Open Zeppelin style like contracts.
Yeah, I think that sort of
Yeah.
stuff makes sense. I mean, it doesn't need to be that complicated. I think some Open Zeppelin people might be here. I
They
saw
are.
some of them
They
around.
are, yeah.
I'm sure they're like soliciting a bid for that or something.
There's a conversation. Yeah.
Right. Something like that could make sense. Maybe something a bit smaller scale. But I think just having, one thing that Ethereum did really well is they had a core set of public goods that people could copy and could use, and it saved them and it saved everyone time. You didn't need to audit the same thing again and again. So I think something doesn't have to be crazy, but something small like that could make sense.
Mooly, we're over time, but do you have final words?
I think I agree with Daniel and Robert, but I think also more tools. More tools will be very useful at any level.
Okay.
More tools, more debuggers, more tools. Not just formal verification, of course, but more testing tools, more tools. You are already doing well, and you have a good spot because you are sort of Rust WebAssembly. But I think more tools will be supplement. Public good is, of course, great.
Will do. Thank you so much. Write secure code. Stop writing bugs. Thank you all. Thank you.